Welcome to The Explainer. Today, we're diving into the silent but deadly world of protocol logic bugs and, well, the groundbreaking tool that was designed to hunt them down. For years, the internet's biggest security nightmares were all about memory. Things like buffer overflows, use after free errors, basically glitches that let attackers scramble a server's memory. So we fought back. We rebuilt our most critical systems in memory-safe languages like Rust and Go, creating what we thought was a nearly impenetrable fortress. But here's the thing. Even inside these shiny, new digital fortresses, a really mysterious problem is popping up. Servers are freezing up, becoming totally unresponsive, and just disappearing from the network. But they're not crashing. So what on earth is going on? Well, it turns out the whole battlefield has shifted. The attackers aren't trying to knock down the walls anymore. They're tricking the guards into locking the doors themselves. Today, we're going to get into how the very logic of a protocol can be turned against itself, creating this silent denial of service that is just incredibly difficult to spot.
Okay, so let's get into the weeds here by looking at QUIC. It's the new transport protocol that's supposed to make the web way faster and way more secure.
QUIC is basically the engine behind HTTP3, and it is an absolute powerhouse. It juggles encryption, multiple data streams, traffic management, all in one package. But all that complexity is managed by something called a state machine. Think of it as a rule book for how to behave in any situation. And that very complexity, well, it's also its greatest weakness. And that weakness gives rise to a whole new class of bugs called logical vulnerabilities. Now, these have nothing to do with bad memory. Nope. These are flaws in the decision-making process of the protocol itself. See, an attacker doesn't need to break your code. They just need to confuse it. And here's where the problem really starts. The official rulebook for QUIC, the RFC, is massive. We're talking hundreds of pages. So you have different teams reading this document and building their software, but they might interpret the rules for some rare edge case situations a little bit differently. This creates what the researchers call a protocol gap, a little bit of daylight between what the spec says and what the code actually does. And that gap, it's the perfect hiding spot for an attacker.
So here's the kicker. These bugs don't cause some big spectacular crash that sets off all the alarms. Instead, the server just gets stuck in a loop, burning 100% of its CPU on total junk and completely ignoring legitimate users. It's a silent denial of service, and it's so much more sinister because, from the outside, the server looks like it's still running just fine.
So how do you find an enemy you can't see? Well, you build a brand new kind of detective. A team of researchers from Tsinghua and Beihang universities developed a tool specifically for this job. They called it MerCuriuzz.
Now, you might have heard of security tools called fuzzers. Traditionally, they're like demolition experts. They just throw a mountain of random data at a program, hoping to make it crash. But MerCuriuzz, it's different. It's a logician. It's not looking for crashes at all. It's looking for signs of confusion, like a server's resources suddenly getting maxed out, or getting stuck in a state that makes absolutely no sense.
So let's pop the hood and take a look at the really brilliant engineering behind MerCuriuzz and see how it systematically sniffs out these subtle, logic-based flaws. It all comes down to this clever three-step process. First, it uses something called segmental mutation to create really unique tests. Then, it watches for weird behavior with state anomaly detectors. And it does all of this at lightning speed, thanks to a snapshot manager. All right, so first up, segmental mutation. Instead of just sending one messed up packet, MerCuriuzz messes with the entire conversation. So imagine the server expects you to say, hello, then how are you? MerCuriuzz will try saying hello and then hello again, or maybe it'll just skip right to how are you? It's testing the server's ability to follow a logical sequence of events, not just its ability to understand a single word.
So while it's running all these chronological tests, its state anomaly detectors are watching the server like a hawk. They're looking for those telltale signs of confusion. Did the CPU just spike to 100% even though no real data is being processed? Is memory filling up for no good reason? If the answer is yes, bam, it flags it as a potential bug.
And to do all this thousands of times a second, it uses a really clever shortcut. The initial QUIC handshake, it's slow, it's resource intensive. So the snapshot manager connects once, takes a snapshot of that established connection, and then just reloads that snapshot for every single test. This lets MerCuriuzz skip the boring setup and get right to hammering the core logic over and over and over again. So, did this new logical detective actually find anything? Okay, you might want to brace yourself because the results were, well,
Absolutely staggering. MerCuriuzz was tested against 16 of the most important QUIC implementations on the planet, and it found 14 previously unknown, brand new logical vulnerabilities. We're talking bugs nobody had ever seen before.
And look, we're not talking about small, obscure projects here. The tool found these logic flaws in foundational code used by giants like Cloudflare and Alibaba Cloud. This stuff affects a massive chunk of the modern internet. And what's even crazier is that these weren't just slight variations of bugs we already knew about. The research uncovered 6 entirely new categories of logical attacks. You have things like a crypto flood, which tricks a server into doing tons of expensive decryption work on junk packets, or the connection hold-on flood, which can trick a server into keeping connections open forever until it just runs out of resources. Let's zero in on one particularly clever attack they found, the connection hold-on flood. It showed up in Cloudflare's QUIC implementation, and it is the perfect example of a silent DOS attack. Here's how it worked. An attacker opens a bunch of connections and then immediately closes them. Now, because of a tiny coding mistake, a developer used the word break instead of continue, the server would process one of these dead connections and then just stop. It wouldn't move on to the next one in the queue. Any legitimate users would be completely ignored, but the server's CPU and memory, they would look totally normal, undetectable. Seeing a bug like that in a major implementation, no less, is a real wake-up call. This stuff isn't just theoretical. So what do we do about it? For all the developers and architects out there, here are the key takeaways. Luckily, the research gives us a pretty clear playbook. First, you need to implement strict state guards. Your code should flat out reject any message that doesn't make sense in the current state of the conversation. Second, you have to monitor for the signature of these attacks. High CPU with low data throughput. That's your alarm bell for a crypto flood. And finally, you have to fuzz the sequence, not just the packets. Test how your server handles a conversation that goes completely off the rails. And all of this really brings us to the final, crucial question we all need to be asking ourselves. As we build this faster, more complex internet, our whole security mindset has to evolve. It's just not enough anymore to secure the data inside each packet. We have to secure the logic of the conversation itself.